Hi guys, welcome back to my YouTube channel, and today I want us to look at part 2 of paper 3 revision as we prepare for biology paper 3 Kcse 2022. Now for this one I have 3 topics: reproduction, cell physiology and growth combined together. So there's a sample question here. You are provided with specimen X. Let's say that X is a portion of raw banana, and then specimens B1, B2 and B3, which are maize grains, and solution R, let's say that solution R is distilled water, and then solution T is a glucose solution. So don't forget this, because we shall be referring to this specimen and these solutions. So you are told identify the type of plant specimen X. So because we say this one is a portion of raw banana, therefore the type of plant specimen is a fruit. So the answer is fruit. So why is it a fruit? Is because it is cut, it is a portion you can see. If you have that specimen, you will be able to see what it has: seeds, has seeds, and then the other one has what? Has a pericarp. Those are the two possible reasons why that one is a fruit. If maybe the question is asking what type of fruit is that specimen X, the type of fruit is a berry, and the reason will be it has a fleshy, non-stony endocarp. And then we come to the other question: make a well-labeled diagram of the cut section of the specimen. So because you are given a portion of it, you are able to see the part that has been cut, and you are able to draw. And from the specimen, a banana is not a circle, it has some edges. So you draw something that looks like that. As an example, the outline must be a thin double line like that, thin continuous double line like that, thin continuous double line like that, and then you draw another part. So make sure that the parts are proportional, something that looks like this, and then this inner part is divided into 3 chambers, 3 compartments like that, and then like that. So a banana, any banana will be like this. So you have here sterile seeds, so you don't use dots, you draw what? To small circles, and then you come and label this part. This part is our what? Epicarp. This part here is mesocarp. This part here is sterile seed, and then the inner part here is placenta. So you just name the most common parts like that. Then you're told what type of section is this one. This one that you have done here is called a what? A transverse section. Correct? Like that. Then calculate magnification of the diagram you have drawn. So what do? You write what? Magnification equals to drawing length divided by actual length. Then you take your ruler, you can measure from this side to this side, get the length. So let's say that from here to here is around what? 6 centimeters. So you carry the units divided by, now you go to the actual specimen, get the length, and let's say that the actual length is what? Something like 3 centimeters. So you come here, show a big X, and then 2 like that. So you get your answer like that. So we are still on our banana. We are told specimen X, name the agent of dispersal. So a banana, the agent is what? Animal, dispersed by animal. Give 2 reasons for your answer. Why do you think it is dispersed by animals? And the answer is that it has what? It has a fleshy endocarp to attract animals. and then the other one, it is scented. Because you have the real specimen, it is scented to attract animals. And then you are told, using a scalpel, you cut out 2 thin peels of the pericarp. So you follow the procedure, and then one you place it in solution what? Solution R, and the other one in solution T. There are 2 solutions, solution R and solution T. And then you're told you leave them for 20 minutes. And we said that let's assume that R is what? Distilled water, and then T is glucose solution. So we expect that the one in solution R, what will happen, the observation after 20 minutes? The answer is that it curves outwards. So the piece will curve outwards. Here, the piece curves what? Inwards. Curves outwards, curves inwards. Then you explain why the one in distilled water is curving outwards, the one in glucose solution, solution T, is curving inwards. And the answer is very simple, that you have to first compare the solutions, solution R and the cell surface. So, what do you say? You say this, something that is very simple, that solution S, solution R, solution R is hypotonic. Remember, it is distilled water. Hypotonic to cell surface of the cells of plant peel. And then what happens next? The cells gain water by osmosis. Cells gain water by osmosis. And then the last part is what? Inner cells. Remember, it is a peel. You have the epicarp and the mesocarp. So the mesocarp is the inner cells, and then the epicarp refers to what? The outer cells. So inner cells or mesocarp cells. Mesocarp cells gain more, it is comparison, more water than the outer cells or the epicarp cells, and the epicarp cells. So because the mesocarp cells or the inner cells are gaining more water than the outer cells, it means then the mesocarp cells will curve more outwards compared to what? The epicarp. So you say, you finish the statement by saying what? Than the outer cells or epicarp cells that are covered by a waxy waterproof cuticle, hence curvature outwards. And then solution T, you say what? Solution T is the glucose solution, in this case, is hypertonic to cell surface of cells of the plant peel. And then cells lose water by osmosis. And then you finish by saying that inner cells or mesocarp cells lose more water than outer cells, hence curvature inwards. So for this one, the mesocarp curves inwards. For the first one, the mesocarp curves outwards. It's because of gaining and losing of water by osmosis. The epicarp is usually covered by what? A waxy waterproof cuticle. So the epicarp cells are not really affected by loss or gain of water compared to the mesocarp cells. Then you are told you you make what? Well-labeled diagram of peel in solution R and T. Remember we said solution R is distilled water, and then for T is what? Glucose solution. So for the one that is gaining water, we said that the curvature is outwards. So you draw it like that. So it is, the strip is curved, the peel is curved, so it is not a straight one. So you have something that looks like that. So you show it like this, show it like that, a thin double line. So this thin double line represents what? Epi, the epi cup, like that, and then the meso cup is the one that will be curving what? Outwards like that. This one is in solution R. Solution R, the piece looks like that. In solution T, the piece will look like this. So this is now the opposite. We draw the opposite of it. The opposite of it is what? That. It is still curved, but now the meso cup is the one that is curving inwards, and then the epi cup is the one that is there. So we have here, this one is our epi cup, this one is our meso cup, like that. So the one losing water looks like this, the one gaining water looks like that. And then fill. So if you're told to fill the pieces in R and T at the end of the experiment, the one that is in distilled water, it has taken in water, so it means it is very firm. So if you're told to fill, you say what? This one is very firm, or you can say that it is very rigid. Very rigid. This one that is losing water in T, you can say less firm, or you can say less rigid, or you can say it is flabby. You choose one of them. It's a flabby. So that means soft. It is a bit soft. And then remember we said the specimen B1, B2 and B3, they were maize grains. So you are told the specimens B1, B2, B3 fruits or seeds. Give a reason for your answer. And the answer is that they are supposed to be what? They are fruits. They are fruits. Reason is because they have what? Two scars. A maize seed is a fruit, has two scars. There's what? Remains of the style at the top, and then a point of attachment to the cob. So it has two scars, so it's a fruit. In fact, if you're told to identify the type of fruit, for maize grain, the type of fruit is Kcse. We call the fruit Kcse. And reason is because the pericarp of maize seed, pericarp is fused with tester. So if you're told to identify the type of fruit is Kcse, reason pericarp fused with tester. But if you're told are they fruits or seeds, they are fruits, reason they have what? Two scars. And then you're told you follow the procedure here, make 3 transverse scars of your banana, place them on what? A white tile, and then you are told that B1, one maize seed is soaked in water overnight, the other one is soaked in hydrochloric acid overnight. You make longitudinal sections of B1 and B3, and then B1 you place it against what? Against the fleshy section of banana labeled 1, because there are 3, you label 1, the other one is labeled 2, the other one is labeled 3. So you're supposed to do what? You're supposed to press B1, section of B1 in to that of fleshy part of specimen X labeled 1, and then B3 to the one that is labeled 3. And then you leave them for some time, like 10 minutes, 15 minutes, and then you add iodine solution. And then you explain, you give observation and you explain what happens after that. So you can see it is here. Allow the setup to stand for 15 minutes, then remove the pieces of B1 and B3, add a drop of iodine solution, and then you do what? You complete the table. So what will you see in 1? The one that was pressed using what? Using a piece of maize grain dipped in water. The observation will be brown color. Brown color of iodine solution remains there. And then here, the one that is what? Pressed with the maize seed that was soaked in HCl. What will you see if you add iodine solution? Blue, black color. And then this the section 2, we did not do anything to this section. So if you add iodine solution, it just remains what? It changes to what? Blue black color. So for this one, the explanation is that starch here is present. Starch is present here. But now for the first one, it was a maize seed that was what? It was soaked in water and then pressed against that portion of banana. So when you soaking activates amylase enzyme, amylase, which hydrolyzes starch to maltose. That is why when you add iodine solution, the brown color of iodine remains. It's because soaking activated what? Enzyme amylase, and enzyme amylase breaks down starch to maltose. So when you add iodine solution, brown color of iodine solution remains because starch now is absent. And then for the third one that was soaked in what? HCl. The reason why you are getting blue-black color is because hydrochloric acid provides what? Provides an acidic what? pH, which denatures amylase. So amylase works best in an alkaline pH, but now you have introduced an acid. The acid denatures what? The enzyme, and because the enzyme is denatured, it means starch cannot be hydrolyzed to maltose by amylase. That is why when you add iodine solution, the color changes to what? Blue black, because the acid denatured the enzyme. The enzyme cannot hydrolyze or break down or digest starch to maltose. And then you're told, make a well-labeled diagram of 1/2 of what? Of a specimen B1. We said B1 is what? Is a maize seed. So if you're told to make a diagram, you draw it a simple diagram like this one. So you show all the parts. So it is triangular. It looks like that, something like that. And then the outline here is a thin double what? Line. A thin double line like that. A thin double line like that. So you have a thin double line. So it goes like that. And then this one is a scar, another scar there. And then you draw it like that, something simple like that. And then this part and that part like that. So this one is what? This one is a remains of style, is a scar. This one is pericarp fused with tester. This one is cotyledon. This one is plumule. This one is a radicle. You just name the main parts. And then this one is endosperm. This one here is endosperm. In fact, if you were to add iodine solution to this section, you will find that the endosperm changes to blue-black, the cotyledon remains what? Brown. Why is the endosperm changing to blue-black? It's because food here is stored in the endosperm in form of starch. Here, in the cotyledon, food is in form of what? Reducing sugars and oils. So the starch has been hydrolyzed to reducing sugars. That is why for cotyledon it is brown in color. For endosperm is blue-black in color. Then state two differences between X and B. So X and B, we said X is our what? Banana, and then B is our maize seed. So even in terms of size, this one is bigger in size. The banana is bigger in size. This one is what? smaller in size. And then the other difference that you can give is that this one is having what? Is a succulent. Banana is a succulent fruit. The maize seed is a dry fruit. And then for maize seed, we say that the pericarp is fused with tester. Here, pericarp not fused with tester. And then sometimes you can be told, name the type of germination shown by a maize grain. You know that the type of germination is what? Hypogyle. And then if you are told to give reason, is because the reason is what? Cotyledons remain below the ground. For hypogyle germination, cotyledons remain below the ground. And then you can also be told to give what? The class to which the maize grain belong. The class is capital M, monocotyledonae. And if you are told to give a reason, the reason is because it has what? Has one cotyledon. Has one cotyledon. Then you are told briefly explain how the type of germination you have named in H1 above is occurs. We said it is what? Hypogyle. So you explain how hypogyle happens. So what do you write? You say what? Epicotyle is very simple. Epicotyle elongates. Epicotyle elongates faster than hypocotyle. Hypocotyle pushing plumule above the ground, leaving cotyledons below the ground. So that is how hypogyle germination happens. So I believe that this last part of biology, paper 3, will help you as you prepare for your final biology paper 3 practical 2022 Kcse. I wish you all the best, and God bless you. Thank you.